Greetings folks, in this video I'll be setting up an AR900 Wing with an iNav board according to the iNav Fixed Wing Group stock build. So that's the group over on Facebook set up by Steve Schlesinger. It's a great spot to go for any help with your first iNav experience, and this AR900 is one of the best wings, I think. Generally one of the best wings, and probably a very good wing to have iNav on it. I haven't yet put iNav on mine, I've just been flying it fun proximity FPV. Anyway, I'm going to follow the recommendations in the stock build, and as such I'm going to be using a Turnigy 2826 1400 kV. Steve actually recommends Racer Star 2212 1400 kV, which is basically the same size motor. Compared to the plug and play, that's a lot bigger and heavier. So we'll see if it gives any better performance. And 30 amp BL Heli ESC, I just use standard ESCs. This is a Turnigy Plush 25 amp. That will be absolutely perfect for this. I'll have a 8x4 APC style prop running on a 3S 2200 LiPo. Receiver will be an FrSky X4R. Any receiver will do that has S-Bus or iBus or PPM, so that you can connect to the flight control board. Flight control board that this is based on is the Matek F405-Wing, which is just a classic wing flight control board. Probably overkill for a wing actually. You may even be better off with a 411 WSE Matek board, but this is my favourite board anyway. I love it. We need a GPS. Recommended is the BN 220. This is a 220T, which is just a variant of the 220. Great little GPS unit, works perfectly with Matek boards. You don't need a compass with fixed wing. The GPS will work out the direction for you, as long as it's moving, of course, with a wing. So this one doesn't have a compass. If you get one of the BN 880s with a compass, you just don't connect the compass. Works perfectly well as well. Video transmitter, you can use whatever gear you want for this, but this is the same as Steve uses, the TS5823L. Costs about $10, $15, 200 milliwatts, 5.8 gigahertz, RP SMA connector. So that has a prong on the transmitter, so you need an antenna with a nut and a hole, basically. RP SMA. Camera I'm using is the Foxeer Monster Pro. So that's a 16:9 aspect ratio FPV camera. I much prefer 16:9 aspect ratio views. Taranis QX7, this is just my radio that I use all the time. On the fixed wing group, they also have OpenTX model file that you can use with iNav as well, already set up with all the switches and everything like that. But I already have my own simple setup for iNav, so I'll be using that. One thing to know is that you have to have a plane that flies well before you put iNav on. iNav can't make a plane fly when it can't fly, when it's not balanced, when the throws are too big or whatever. So I've been flying this for 3 years, flies beautifully now. I had the servo connections. There are 4 holes down on the servo arm there, because the throws would have been way too big if they're on the outer hole there, so that sort of tames down the throws. I have the trim set correctly by adjusting the length of the push rods. You have to do all of that stuff first before you consider adding a flight control board. So let's get to it. This wing will work with a variety of power setups. One recommended in this build weighs around about 100 grams for the motor and ESC. The one that mine came with, the original plug and play version, which I think must be different to the one that Steve has tried, weighs about 47 grams, because this setup for me worked absolutely perfectly. There's no lack of power at all. Anyway, the message is you can use a large variety of power setups with this wing. I actually prefer the lighter builds myself. Servos, it's probably always better to go for a Metal Gear servo, just for longevity and toughness, so that when you crash it's not going to strip the gears. The Tower Pro MG90S from Banggood is one of the cheapest servos around. It's rough and ready, but it's tough and will last for ages. One of my favourite servos over time has been the Turnigy TGY 9018 Metal Gear. That's a little bit more refined, a little bit more accurate than the Tower Pro. Analog or digital, it doesn't really matter. I think the theory is with digital servos you can get faster response and more accuracy, but it doesn't make a major difference as far as I've found. Here's my flight control board. This is from another project, so it's already soldered up. You may want to think about how long you make your wires so it's going to fit into your spot nicely. I tend to just solder on the pins that I need. Need to be very careful with the little USB socket there. That's quite delicate and can break off quite easily, so I often put some supporting epoxy glue around the bottom of the socket there. There's the little arrow that tells you the board thinks it's going to be facing that way when it's mounted. You can rotate it around if you want to. ESC motor there. S3 to S8 are the servo outputs. We're only going to use 3 and 4 there. So here's the camera and video transmitter connection, and Steve makes the point that you have to take very close look at how these are laid out. There's the signal, ground and 9 volt. If you look at a normal servo cable, it is not the same. It's signal, voltage and ground. So if you were to wire up your video camera, video transmitter using a servo plug, you would have to remember to swap the ground and the power cables. I've taken a different approach. There's another ground available out the side here, so I actually use a 4-pin plug. You can get these on eBay. Just search for DuPont connectors and you can get a box of all different numbers of connectors, because I know that if I switch over the ground and the power on a 3-pin plug, I'll use it eventually for something else and it'll blow up whatever I'm connecting. So this 4-pin plug, using signal, not using that ground there, but using the power and ground on the outside there. That one is always going to be safe to use because I won't mix it up with something else. So I've done that for the camera and the video transmitter. Those two just plug in there like that. Around this side we have the S-bus connection there and the GPS connection there, and that's just an extra set of pins for something else that I was trying, but we don't actually need that for this build. And the ESC connections, signal and ground there. You don't need power coming from the ESC to the board. The board gets its power from the LiPo. If you're going to plug this straight into these pins here, you will need to remove that red wire there because that provides 5 volts and that will just confuse matters. And also you'll see the signal wire and the ground wire are next to each other, which they're not in this 3-pin plug here. So again, you're going to have to move pins around. Remove the red wire and move the ground wire over into the spot that the red wire is in. I do have 3 pins soldered on here. That 3rd pin there doesn't get connected to anything. That just sort of helps support that when it's plugged in. GPS connects to a UART, so that's one of these connections with the ground, the 5 volts, the T and the R, T2 and R2. If you look at your GPS, that will have ground, power and 2 other wires, and one will be RX and one will be TX. A thing to note with any UART connection is that the RX cable from the device plugs into the T pin on the board. So R goes to T, T goes to R. Doesn't matter if you get them the wrong way around, it just means that the GPS won't work. So if you plug your GPS in, the power is on, everything else checks out, but the GPS isn't working, try just swapping the RX and TX pins over. So, but on this one, the RX from the GPS is green, goes to the T pin, and the white coming from the GPS is the TX, goes to the R pin. Once again, I've soldered up a 4-pin plug to go in there. So that plugs in like that and is correctly connected. So now thinking about layout, there's an obvious spot for the FPV camera that just goes in there, and there's a sort kind of a channel for the cables to go through. I think I cut that little bit there so it comes in, and I'll just tape over that. The board will fit right about there. ESC produces the most noise of all the components, so I'll sort of want to get that out of the way, so that'll end up being right back in there as far as possible. GPS, important to note that that is upside down. You need to have this foil antenna facing upwards. Can be under the foam, that doesn't matter, but as long as it's facing up this way with the brand name facing down, that will go somewhere, just as long as it's away from all the noise, somewhere around here maybe. We'll work out that later on. Receiver, we want the antennas to be away from the GPS and the ESC as much as possible, so that will antenna wires will be out that way somewhere. You can place it right out on the wing, but it means you have to dig holes in the wing, which I'm a bit reluctant to do. Video transmitter, again, you want to keep that away from the receiver and away from the GPS and away from the ESC, so that will be, I often have mine just sitting up on top on the canopy there, but you can put it, I don't know, somewhere else. We'll work that out in a little while. And the battery just fits right in there. See the ESC and plug all sort of fit in there nicely, giving me plenty of space for the board. I might glue this bit of plywood on there, and I have a couple of 3D printed brackets which sort of screw into that, so that's a nice sort of removable way to mount the board, so I'll do that. I'm going to use some 5mm epoxy, because with gluing timber to timber, epoxy is the best stuff for that. For the moment, I'm just going to pop the GPS out there and sort of tape the wires on top. You could dig a hole and bury it into the wing, but I don't know if that's where I want it to end up at the moment, so just have a temporary mount. My receiver is just going to be sitting in here in the side, tucked away out of the way. We really just want to get the antennas away from any other noise producing source, which is the board and the ESC and the video transmitter. Video transmitters will be over on the other side, so we'll just tape the antennas out here. This isn't a super long range build, so you don't have to be too pedantic, as long as you're not hiding behind the battery or a carbon fibre spar. You can actually have one sitting vertically too if you want to do it that way. It's threaded up into there, but I'm just going to tape it out on the wing for the moment. One sort of laterally and one horizontally. Just have the video transmitter sitting up on top like that. It was working reasonably well. I might just leave it like that, actually. That's the easy option for the moment. For better reception, you might want to put that right out on the wing and bury it in the wing, but I don't want to dig up too much foam at the moment, so I'll just pop it up on top there and see how we go. I've swapped to a longer antenna to get a little bit more height, give it a little bit more clearance, and I'm just going to cable tie this on. I've got a little bit of a backing plate under there and just poked a couple of holes, so that will just cable tie on with the heatsink up on the top to get plenty of air cooling. Now my board has already been calibrated and pretty well set up from a previous build, so I'm not going to redo it, but if you look at the AR Wing build, they provide suggested PIDs and tuning values, which I'll enter them manually. They also provide the iNav configurator file, or the commands. You can copy all of them and just paste them into the configurator, into the CLI. I'll show you where. Let's connect it all up. So I can click connect now. I'll quickly go through some of the pages to show you what we do anyway. So this file, you just copy all of this and paste it into the CLI down here, hit execute, and it should load all the settings for you. But I'll just go through what I have set up. So set up to start off with. That shows that the animation is reacting to the movement of the board, which is great. I'll turn my transmitter on too. So initial setup screen shows that the animation is moving with the plane, which is good. Calibration, you need to do your calibration for each new firmware update or each new board. The mixer, we need to pick airplane as the platform type, and flying wing. So we have two motors, we don't need two motors, we can delete motor 2. And we have the elevon mixing for the plane, for the flying wing. And this is why you don't do it in your transmitter, because it does the mixing in the mixer. Save and reboot. Then we go to outputs. Need to make sure motor and servo output is enabled and stop motors on low throttle. I'm just using a standard ESC, so this is where you would set the ESC protocol. I think Steve's suggestion is 125 from a BL Heli, maybe. But yep, standard is all I'm using. And if you're using analog servos or even slow digital servos, this should be set to 50 Hz. If you're using fast digital servos, you can increase that servo refresh rate to get, in theory, faster response from the servos. But for normal use, 50 Hz is correct. And if one of your servos is moving in the wrong direction, this is where you do the reverse. It looks like I've had to hit reverse for S3 for my setup. You can also adjust trims here. You don't do it on your transmitter, you'll do it either by doing an auto trim, adjusting the push rod lengths, or by doing it here. Presets, no, that is not for us. Ports, I have the S-Bus connected to the S-Bus pins, which happens to be UART2, and the GPS on UART4. Configuration, let's go through these. I usually have about +3 pitch degrees for board alignment, and that helps the plane to fly level in angle mode. The angle mode relies on the alignment of the board, and planes usually have to fly with a little bit of up angle of attack, so +3 works for me. Receiver mode, we're using a serial receiver and I am using S-Bus. Have to turn on, use GPS for navigation and telemetry, otherwise you won't see the options later on. There's the same stop motors on low throttle, enable OSD and enable motor and servo output. These should all be automatically selected if you loaded the file from the build. Depending on your receiver, you'll either tick analog RSSI if you have a physical wire connecting from your receiver to the flight control board for RSSI, or if your RSSI is coming down a channel, then you'd untick that. Failsafe, click return to home. PID tuning, this is where the suggested values will be entered. We're going for the cruiser build, so the P for roll is 4, so I'll change that to 4. Pitch is 5, and yaw, there is no yaw on the wing, so we don't worry about that. The I is 10 and 15. And the feed forward is 40 and 50. So that's good. I think the build file does give some thrust PID attenuation and breakpoint, but I don't really worry about that. That sort of calms down the stabilization and the throws as you go faster, but I've never found I've had to do that. Let's go to rates and expo. So the suggested roll rate is 280 degrees. Suggested maximum pitch rate is 120. Maximum roll angle 45. And pitch angle of 30. So I'll save that. The roll rate in degrees per second is the maximum roll rate you can get out of your wing and the maximum pitch rate you can get out of the wing. And you need to work these out yourself and tell iNav here these values, because they're sort of the maximum targets that iNav will aim for when it's controlling the plane. And each plane is different, so you need to go out and fly at a decent speed and do as fast a roll as possible and time how long it takes, and then divide 360 by the amount of seconds, and that'll give you this number here. Make sure we save that. Advanced tuning, determine what sort of return to home you want. I do at least linear, I like that one. Return to home altitude, I think it's preset at 10 meters or 1,000 centimeters, which is totally wrong. I go for 50 meters, and I change land after return to home to never. You've got the loiter radius here, you've got the maximum bank and climb and dive angles while it's under GPS control, so I usually don't mess with them at all. Now we can look at the receiver, and this is where you check whether your receiver is working correctly, whether you've programmed up your transmitter and receiver properly, and you'll see as I'm pushing the sticks up and to the right, all those graphs go up. That's the correct way. Now I notice my pitch is going up to 2006, so I need to adjust the endpoints in my transmitter for that channel so that it only goes up to 2000. And down to 1000, they're all correct. Need to make sure the throttle can go down beyond 1000. I'm using my own OpenTX iNav model. Now if you're using Darren Lyne's OpenTX model for iNav, all these switches might be different. So if you're going to load that and load the iNav build, then it'll all work for you, hopefully. But this is sort of my own setup. Modes, these are just how I have my modes set up. I won't go through them because that'll be different to the suggested ones, I guess. OSD, this is my own OSD. And I have 3 different OSDs. One normal one like this, which includes height and distance. Alternative one, which hides the height and distance. And I have a tuning one, which includes the PIDs, so that I can do an auto tune and see how these change. So I put the plane outside so we can pick up some satellites. You may not see that, but that says 8 satellites. I've got RSSI showing up there, I've got the mode showing there, and that's my sort of default OSD screen. That's my tuning screen, which includes the PIDs, and this is my recording for public use screen. Now with just the battery in there, that's a little bit tail heavy, so I will have to put a Mobius in there or a GoPro or something like that, or even just this little bit of lead. Let's try this. CG is right on now. About 65 grams of extra lead just to balance it, which sort of allows for you to add a camera, and that all up weight is about 740 grams. Now it's a good idea to check your throws once you're all set up, and this is the pitch throws, and compare it to what you get with manual. So that's my manual pitch, and that's my acro pitch, which is not enough, I don't think. So if I were to launch in acro, that's all the amount of pitch that I would get. That'd be fine for flying around in stabilised mode, but not very good for launching, I don't think. Pitch feed forward is about 50, so let's increase that. So that's gone up to 80 to show you. That's manual and that's stabilised. That should be enough throw to start off with anyway. So I've changed the pitch feed forward to 80. The roll seems fine. I'll leave that at, what is it, 40. Alright, now we're ready to try it out.